Again, if you're watching videos, I have changed the sound quality. Everything should be up to par and good to go. But we turn to problems 3 and 4 in your notes if you want to find that spot. And here's the idea. The derivative of the inside, 10x. Derivative of the outside. What's the derivative of secant? Secant tan. So the derivative negative 4 secant will be negative 4 secant of u tangent of u. So I get negative 40x secant of 5x squared tangent of 5x squared. So you can see I didn't use the boxes there, did I? So we want to get used to, and I'll do it again today later on, where we take the derivative without setting up the boxes. We think of it as derivative of the inside times the derivative of the outside with the inside left alone. Okay, that's how we try to think of it. So let's try number 4. For number 4, I will write the boxes, and I'm going to rewrite this problem as negative 5 times what? Instead of divided by, I'm going to write times. Times what? X plus 5 to the negative 7th. I set up the boxes. What's the inside? X plus 5, the outside. Derivative of negative 5 u to the negative 7th is 35 over u to the 8th. Derivative of x plus 5, 1. That's awesome. So I get f prime of x is equal to 35 over x plus 5 to the 8th power. So, congratulations. You're excellent at the chain rule when you only have to do it once. But what about when it's in context of more challenging problems? Say 6 and 5. Problems 5 and 6. Those are a little bit more difficult. What makes problem 5 unique compared to the other ones that we have covered? You have the x on the outside. And what that tells us is that you have one function times another function. Would you agree that this is the product rule? So I will set up f prime g plus g prime f. What is f prime? Times g, which is 4 minus x to the 4th power. Instead of writing g prime, I'm going to write f right away, so plus 2x. And then I have to do g prime. How do you find g prime? I need the derivative. Yep, chain rule. Derivative of 4 minus x to the 4th will be the use of the chain rule. What's the inside? 4 minus x. Outside. U to the 4th. Derivative of u to the 4th. 4u cubed. And derivative of 4 minus x? Negative 1. I multiply them. I get negative 4 times 4 minus x to the 3rd power. Now, although this is a derivative and it is acceptable in form, this is not how you will be asked to leave your answer on the test. And I will tell you why. The AP exam, as well as your book, want this to be written in factored form. So when you come up with this type of scenario where you have a binomial or a trinomial to a power, they will ask you to take out the common factor. What factor do these two share in common? 2 times 4 minus x to the 3rd power. Watch what happens when I take out that common factor. What is left here? 4 minus x. What is left here? Minus 4x, right? I have an x as well. Can I simplify this? Combine like terms and you get 4 minus 5x. Now, I would say that that is acceptable on the test. I can't tell you whether the book would write it like this or if the book would write it as 8 minus 10x times 4 minus x to the third power. So I multiplied the 2 through that binomial. I don't know how they'd write it. The AP exam might choose either way. But I can guarantee that the AP exam most likely will not leave it like that. I took the 2 and I distributed to the 4, and the 2 distributed to the 5. How's that? Okay. I'm going to show you another example that is trickier in terms of involvement of the chain rule. And this is a classic example. You'll have to know how to do an example like this for your test as well. Sine squared of 3x. I'm going to rewrite this as sine of 3x, that quantity squared. That's what that means to say sine squared of 3x. I told you, always identify the inside first. Well, that's not the case in this situation. Do you see that I'm squaring this thing? So the outside will be u squared. What is it that I'm squaring? Sine of 3x. So if people are not doing this carefully, they will often identify the inside as 3x, where the inside needs to be sine of 3x. What's the derivative of u squared? What is the derivative of sine of 3x? What do I have to do to find that derivative? Close. It's not cosine of 3x. I have to use the chain rule, don't I? What's the inside? What's the outside? What's the derivative of sine? What's the derivative of 3x? So the derivative of sine of 3x is 3 cosine of 3x. Agreed? So I used this to figure out this box right here. Now I multiply these together, and I'll get a 6, a sine of 3x, and a cosine of 3x. And that is f prime of x, my derivative. I multiply the 2 and the 3. I plug the u in, and I put the cosine after. So you saw one where you used the product rule and the chain rule. You saw one where you used the chain rule twice. Go get some brain food. Come on back. So there you go. Let's flip it over to the next side. Hopefully you guys had a good lunch. We're going to skip example 1, A, B, C, and D, because I think you already know how to do that. Those are examples where we do just one step of the chain rule. And you guys got great at that yesterday. So let's move on to more difficult things. Example 2. This is going to require the use of the chain rule. Well, what other rule are we going to have to use? Product. See if you can do it. Go. I would like you to try on your own, and then for you to share with me where you made your mistake. You learn more when you try on your own. Here we go. This is the derivative. So Kelsey is identifying right now. She's wondering about this 4 right here. In order to take the derivative cosine of 4x, you must use the chain rule. So you have 4x, you have cosine of u, negative sine of u, and you have 4. That's how we get the... So the derivative of negative 3x squared was my negative 6x, times that left alone, minus there's 3x squared, and then this 4 times negative sine of 4x, that's the derivative of cosine of 4x. You have to use the chain rule there. Go Tigers. Go Catherine, wherever you are. Sure, go ahead. This one? In the chain rule, when I take the derivative of cosine of 4x, pops up there. Anybody else make a mistake that they could share with us? You can, but you don't have to in this situation because it's not, nothing really combines together for like terms. So, yep. Do. Okay, let's try next one. Anybody see the 2 rules that we have to use here? Quotient and chain. Now, if I plug in a number for x, let's say I plug in 1. This is how you tell what to set up first. If I plug in 1, I'll take 2 minus 1. I'll take 2 times 2 plus 3. Will I divide those, or will I take the square root? Which will I do first? You tell me. I divide, and then whatever I get, I take the square root, correct? So since the square root is the last thing that you do, that is the outermost structure of your derivative. So the square root requires the use of the chain rule. You're going to want to write small here because it's going to take up a lot of space. So my outside is the square root of u. What is the inside then? I'll admit, a lot of people don't know what to set up when we get to these type of situations. Yes? You could write it to the 1/2. Yes. Now that I have that, I use the chain rule and I take the derivative. What is the derivative of 2, or I'm sorry, of a square root of u, or u to the 1/2? Ends up being 1 over 2 roots of u. That's something you have to get used to. So 1/2 u to the negative 1/2, or 1 over 2 roots of u. How do I find the derivative of 2 minus x over 2x plus 3? Quotient rule. So f prime g minus g prime f all over g squared. What is f prime? Negative 1 times g, 2x plus 3, minus, what is g prime? 2 times 2 minus x, all over the bottom squared. What does the top simplify to? Looks like I'm going to have a negative 2x and a positive 2x. Those will cancel, right? I have a negative 3 and a negative 4, which make negative 7 over 2x plus 3 quantity squared. Now I have to multiply those 2 together, don't I? Now, I'm going to write this as 1 over 1 over 2 square root of 2 minus x over square root of 2x plus 3. I am plugging this into here. And it's going to be a complex fraction, isn't it? You're putting a fraction into a fraction. So what I decided to do is write the 1 over 1. And this is a 2 over 1, right? So the 2 is here. And then I took the square root of the top and the square root of the bottom, which is totally legal. Times negative 7 over 2x plus 3 quantity squared. Now, what will I do with this? Flip it. Yeah, just multiply by the reciprocal, right? So when we multiply by the reciprocal, what we get is in the numerator, we get a 2x plus 3 to the 1/2 power. On the bottom, we have a 2 times the square root of 2 minus x. Right? Well, as I multiply these two together, what do you notice about the 2x plus 3 here in the denominator? What's going to happen? They have the same base, so what do we do to the exponents? Subtract. And 2 minus 1/2 is 3/2. Will the 3/2 be in the numerator or the denominator? Denominator. So that will cancel, reducing that to 3/2. So I get negative 7 over 2 roots of 2 minus x times 2x plus 3 to the 3/2. That's my derivative. I agree, kind of icky, huh? You threw up a little bit in your mouth? So we're just going to do one more problem today, and then we'll leave the rest for tomorrow. We're going to do problem D today. I'm going to leave C for tomorrow. Letter D is a little bit complex. I'm going to rewrite it. Does everybody see why I can write it like that? A lot of people would put the negative 8 on the inside of the parentheses as well, but negative 8 is not being taken to the 4th power. Only the operation of sign. That's why I write it like that. You're taking the sign of that, and then you're taking the sign to the 4th power. So, no, the 4x minus 2 is not being taken to the 4th power. So, what rule do you think I have to use? I do have to use the chain. The question is, can you identify the outermost structure of the chain rule? Very, very good. Negative 8 u to the 4th power. So what is the inside? Suppose instead of identifying that the outside was negative 8u to the 4th, and you try to identify the inside right away, what do you think you would have listed as the inside? 4x minus 2, okay? So we want to set it up like this, okay? And the derivative of negative 8u to the 4th, in order to take the derivative of sine of 4x minus 2, what do I have to use? Chain rule. Instead of setting up another set of boxes, we will just think about it, okay? If you want to, but there will come the time I won't. Watch. Just watch. Just watch. What's the derivative of the inside? What's the derivative of the outside? Cosine. With the inside left alone, And you can go ahead and make the boxes, but for the sake of time, there are many times in the class where I will refer to the derivative of the inside times the derivative of the outside with the inside left alone. And I believe that that is a nice way to go about it. So now I can multiply these together. I get a negative 128. What is being taken to the third power? Sine is. So I have sine cubed of 4x minus 2. And what else? So I got rid of the 4. I got rid of the negative 32. I got rid of the u to the third. What else do I need? Yeah. That's a sweet derivative. Yeah, exactly. And now that's, Caleb, you're starting to mesh. That's what I would always think of. I wonder what that looks like. I want to graph it, you know? If you'd like to, go ahead. For the sake of today, I want you to know that your assignment, it's amazing. College algebra is already freaking out about their math tests. They got one tomorrow. They had a work day yesterday. They had a work day today. Like, what more do they want? Like adding and subtracting. Um, so anyway, here's the deal. This is your assignment. It is rather lengthy because you need the practice with this stuff. This stuff is super important. Now, 7 through 43 odd, and then add these to it. I want you to know that problems like 57, 58, some of these we are going to do tomorrow. So we have about 3 problems to do tomorrow in class. And once we see those, you should be good to go the rest of the way. So Claire may have the first question, and Maddie may have the second question. Good day to you, Miss Catherine Flaherty and Claire Sherman. I'm sorry, Allie Sherman. We missed you guys. We hope you're well. Shout out to all my YouTube video people. I crossed the 70,000 view threshold. I'm looking to reach. I know. Thank you. I'm looking to reach 100,000 sometime next year. We all have our goals. I'm gonna reach 100,000 YouTube videos, and our national debt within about 40 years is set to reach 1 quadrillion. We all have our goals in life. Go federal government.